Cool. This is Venkatesh from Mannar Human Store Technology. And for the hackathon, I had built Blackfence, an anomaly detection model based on isolation forest for network anomaly detection. So at first, we will be initializing the model with the baseline rate. Let's say, let's give 40,000 and see whether it works or not. The model will be training at the CPU. It's literally less than an MB. So the model has been active and it has been trained with the sample. So this is the current dashboard in which we'll be getting anomalous detection active rules which has been provided. Let's do a traffic analysis. So it is based on the already available dataset which I loaded. Manual input can also be done. So I'm clicking none analysis. So that's it. You can see in the dashboard that new threat and anomalies has been detected. So around 5,000 seem to be normal traffic and around 4,754 anomalies has been detected and it has been tagged as low and medium accordingly. And you can see in the graphs as well, the anomaly detection threshold has been set to 0. Anything more than 0 will be tagged into low, medium, high and critical categories. And the top recent alerts are also seen in the dashboard. Let us do a manual input so that we can see. And for the futures that I'm considering, currently I'm using CACDS 2017 dataset, which has around 68 futures for better detection. I suggest minimum 10 futures in this should be included in the CSP. So let me browse. It is an example for critical test. And you can see the data as well, the port numbers, everything. So by analysis, you can see that in the 19 flows, 19 are seen to be anomalous, and the scores has been mentioned below as suggested. And for now rule generation, we can generate rules based on the dataset samples that we currently have. Let's say around 5,000 samples, and there are four dataset sources that I have right now. Let's check for web attacks. It takes a bit of time. So the generated rules will be visible here. Here you can see the rules has been generated for web attacks based on the baseline scenario that we done earlier. We can export it as JSON or we can export it as mod security format, which can be given into integration into Apache or Nginx for real-time integration in WAPs. This is the current format that I have been working with. So you can see the rule ID, the description, the severity of the rule. So in which way we are generating auto generation of rules using Z scores. And we do have reports as well. Currently we can export the log and we can generate a PDF report. It shows the detection accuracy, performance and F1 score. I'm clicking generate report. So we have export rules PDF. We can export the rules that we had created just now. For example, I will open the generated PDF. So you can clearly see that the report contains report ID, generation at, and what are the classification that we have. Currently, we did manual report which has 19 anomaly and it is tagged as complete anomaly distribution. And high severity anomalies are rated based on scores. So that's how the report works. The total flow analysis and anomaly rate has been directed right here. It can be used for precursor report before the final report that has been evaluated. So that's it about report generation. One can export the log PDFs as well. And now the dashboard. You can see the anomaly detection has been updated to 19 due to the manual thing that we did. And we had generated 86 rules based on web attacks that we did right now. And the recent score also been updated to medium based on the scores that we did right now. You can see the graph has been changed as well. So that's how the current module works. Uh, in the futures, we have HTTPS enablement so that the port-based attacks also tagged as a feature that zero-day attacks doesn't happen. So other than that, I have to show the documentation. I had also included the documentation of how it all works, the score ranges that we had, and the performance metrics that I have, and the calculation of Z score based on the flow, the baseline calculation, and so on. I also included rule generation calculation as well, so that the generated rules doesn't be any abstract rather than having a correct explanation for it. So that's how the system works currently. For testing purposes, one can add manual input. One can drag their own CSV and check in the dashboard. And for rule generation also, one can create their own rules as well. So that's Blackfence from my end. And in the classroom, I had also included Docker files as well. If you want to run in containers, that's possible as well.